All right, just like the other night when we did arithmetic, tonight we're going to be doing geometrics given a recursive determine the explicit. So here we go. F of 1 equals 12 and f of n equals 8 times f of n minus 1. So our explicit begins at an output of 12, is multiplying by 8 repeatedly to the power of n minus 1. As a quick reminder, where do these things come from? This time 1 shows up here in the explicit. This 8 that's my multiplier shows up here, and the 12 starts from here. Notice that I'm using a repeated multiplication exponent in these explicits, so all of these should have a power, a little tiny n up as a power. Okay, let's go try the next ones using that same format. This function begins at 10, is multiplying by a negative 2. Did you know we could do that? It's not minusing 2, it's multiplying by negative 2. And this is just to a power of n because it's times 0, or n minus 0, you can write it if you want. But just to a power of n is plenty. Here comes your next one. Begins with 7 times 6 to the power of n minus 0, or just n. Next one is an f of 1, so here we go with a power of n minus 1 again. So this begins at negative 15. Multiplier is 5 to a power of n minus 1. So again, where do these parts come from? Just a reminder, the 1 shows up here in the exponent. The multiplier shows up here as the r, or the multiplier, common ratio. And the negative 15 is our output given right there. Okay, try the next one. A function that begins at negative 7. Do you want to put a parentheses around that? Does that make you feel better? Do it. All right, and then to the power of n. n minus 0 or n would work there. F of n equals begins with 16, multiplying by a half to a power of n minus 1. All right, now it's going to reverse, given the explicit, do the recursive. So f of 0 equals negative 10. How do I get that? Well, right here, we see it's a plain n. There is no minus 1. That means it's a times 0 function right here. Then we see that this begins at negative 10 here. So there's my f of 0 equals negative 10. We then say the next term is equal to the previous term times 3, or you could put the 3 in front, both work. F of 1 equals 65. Look to see if you understand that. F of n equals f of n minus 1. You got it, times 3/4. And finally, f of 1 equals 8. F of n equals f of n minus 1 times 10. Okay, geometric means on the next ones. So we're looking at building this explicit function like this. We begin at 12. We multiply repeatedly 1, 2, 3 times, or r to the power of 4 minus 1 times, and then we should land at 324. So using the table to build my equation that I'm going to solve, I'm going to get r cubed is equal to, grab that calculator. You got it, it's 27. And we know we can take the cubed root on our calculator, cubed root of both sides, and my multiplier is going to come out to 3. So 12 times 3, 36. 36 times 3, 108. 108 times 3, yes, that gives me 324, good job. And then 324 times 3, 972. So don't forget to fill in the blanks after as well. Okay, pause the video, try the next one, see how you do. Should have started at 32. R to the 5 minus 2 power is going to equal negative 256. Interesting. So divide by 32. R cubed take the cubed root of both sides, and we get cubed root of negative 8. Do that on your calculator. We get a multiplier or a common ratio of negative 2. So 32 times 2 would be 64, but this needs to have a negative. Negative times negative is going to give us positive 128. in the next step. Notice how the negatives and positives are going to alternate as you multiply by -2. Then going backwards, we would divide by -2. Does that make sense? Pause the video, try your last one. This one's going to be to the 3 minus 1 power, or squared. Should land on 16. And you're going to notice this time we've got a fraction. So r squared is equal to 1/4. And if I square root both sides, the rule for radicals is I can square root the top and square root the bottom. So I'm just taking half of everything. Now, if you had done this on a calculator, you'd get 16 divided by 64 gives you 0.25. So you'd get r squared equals 0.25. And when you square root that, you get 0.5. So whether you did it the decimal way or the fraction way, the point is it's halving. So 64 divided by 2, or half of 64, is just 32. And then 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. How'd you do? All right, last but not least, given a sequence, write the recursive, write the explicit. What's the 10th term? Then there's another one. So here we go. Did you notice we're just multiplying by 3 here? And so grab your calculator. 216 times 3, that's going to be 648. 648 times 3. You're going to need a calculator for these big numbers, so prepare yourself. And then it's assumed time 1 whenever we're given a sequence, right? So f of 1 equals 8. F of n equals f of n minus 1 times 3. And f of n begins with 8 multiplying by 3 to the power of n minus 1. We then do the 10th term. Grab that calculator. 8 times 3 to the power of 9. And I get 157,464. Okay, pause the video, try the next one. Let's see how you do. All right, this one, from a 50 to a 43, from a 43 to a 36, from a 36 down to a 29, we know that we're working on geometrics, so this is going to be a fraction multiplier. So if I grab my calculator and do 43 divided by 50, I get a decimal of 0.86. Now I'm going to take 36 divided by 43, and I get 0.84. If I do 36 divided, oh, just kidding, that's one I already did. If I do 29 divided by 36, I get 0.81. So this is not the same ratio that's happening every single time. So what about subtraction, old school? Maybe it's not geometric. Well, guess what it is? It's just testing you. What if I go 50 minus 7? I get 43. What if I go 43 minus 7? I get 36. What if I go 36 minus 7? So this was an arithmetic thrown in there kind of to test you and make sure you don't just go with the first geometric ratio. You always need to see that constant ratio, the same ratio over and over again, or it's not geometric. So here's our arithmetic thrown in here. We're going to begin with begin with 50, subtracting 7, big N minus time 1. Okay, I can't really fit this, so let's see where I want to write this instead. So this is not geometric. Let's go 29 minus 7, 22. 22 minus 7, 15. 25th term into this arithmetic sequence. Notice that I'm plugging in a 25 wherever there was an n. Okay, 50 minus 7 times 24, 50 minus 168 is going to be negative 118. How'd you do? All right, that's page 12 for you guys. Good job.